There may be a watery surprise on a Neptune-like planet that is relatively close to Earth. Neptunian exoplanets resemble our solar system's Neptune or Uranus in size. Neptune has a radius almost 4 times that of Earth and a mass nearly 17 times that of Earth. The interiors of Neptunian exoplanets could vary, but they are all likely to be rocky with heavy metals in their cores. The atmospheres of Neptunian planets are often dominated by hydrogen and helium. Many Neptunes, planets that are larger than Earth but smaller than Neptune, are also being found. In our solar system, there are no planets like these. Neptunian planets often have cores made of rock and heavy metals, and atmospheres that are dominated by hydrogen and helium. Though the findings are still preliminary, it's possible that the exoplanet TOI 1231b has clouds of water high in its atmosphere. Jennifer Burt, a scientist at NASA's Jet Propulsion Laboratory in California, said that future observations of this new planet would allow scientists to ascertain how typical or unusual it is for water clouds to form around these temperate worlds. Observations of TOI 1231b indicate that the planet has a sizable atmosphere, but the researchers cautioned that they are yet unable to determine the planet's exact makeup. The water clouds may be contained by a dense water vapor atmosphere, according to models, or it may have a more substantial hydrogen or hydrogen-helium atmosphere, like Neptune. The confirmations might appear rather soon. Given that TOI 1231b is only 90 light-years from Earth, major observatories should have little trouble locating it. The James Webb Space Telescope, operated by NASA, is designed to study planets with atmospheres, particularly gas giants. The team will have the opportunity to conduct observations using the Hubble Space Telescope even before that, as one of the paper's authors has reserved telescope time on the 31-year-old observatory. NASA released a statement announcing the discovery, saying that scientists should be able to utilize the Hubble Space Telescope and, shortly, the much more sensitive James Webb Space Telescope to catch starlight shining through the atmosphere of TOI 1231b. Slices of light from this spectrum will be absorbed by molecules in this planet's atmosphere, creating black lines that can be read like a barcode to identify the gases that are present. In addition, Hubble will search for signs of a planet's tail, which would show up if hydrogen or helium atoms could be seen as the planet passed in front of its star. Because they resemble interstellar gas so much, hydrogen atoms are typically very difficult to distinguish, according to the study. The planet-star combination in this instance, however, is traveling fairly swiftly away from Earth, and this speed presents an interesting opportunity to detect potentially faster hydrogen atoms against the background of a slower star system. When TOI 1231b was discovered by NASA's Transiting Exoplanet Survey satellite and confirmed by the Carnegie Planet Finder spectrograph on the Magellan Clay Telescope in Chile, we did learn a few facts about it. The diameter of TOI 1231b is about 3.5 times that of Earth, making it slightly smaller than Neptune. With an orbital period of 24 days, TOI 1231b also approaches an M-dwarf star that is only 90 light-years from Earth. Proxima Centauri, the closest star to the Sun, is a red dwarf. With a relatively chilly atmosphere and a temperature of 140 degrees Fahrenheit or 60 degrees Celsius, TOI 1231b orbits its star closely. Clouds can occasionally be seen high in the atmospheres of cold planets. Scientists can determine whether TOI 1231b has water clouds by comparing it to other exoplanets that are comparable in size and temperature. Being wonderfully chilly in comparison to the majority of transiting planets discovered so far, TOI 1231b, which can have sweltering temperatures in the hundreds or thousands of degrees. Clouds may exist in the atmosphere of planets with such low temperatures, according to earlier study. Comparable exoplanet scientists were astounded when they saw indications of water clouds in the recently discovered K218b. This exoplanet is 124 light-years from Earth and is in orbit around the red dwarf K218. The planet, which was first spotted by the Hubble Space Telescope, has a mass that is roughly 8 times that of Earth, making it a super-Earth or a mini-Neptune. It also has the potential to be a Hyson planet. It travels in the star's habitable zone on a 33-day orbit. Future investigations of this new planet will allow us to ascertain how frequently, or infrequently, water clouds occur around these temperate worlds, because TOA 1231b is the only other planet in this size and temperature range that we are aware of. Despite being positively freezing in comparison to most transiting planets, such as hot Jupiters, which normally reach sweltering temperatures in the hundreds or thousands of degrees Fahrenheit or Celsius, Bert said TOI 1231b is more than double Earth's average temperature. It can be challenging to infer a lot about the compositions of faraway planets. By examining starlight, space observatories like NASA's Hubble and formerly Spitzer may learn about the atmospheres of planets. Atoms and molecules in a planet's atmosphere absorb light at specific wavelengths, obscuring it from the telescope's field of view as starlight travels through the atmosphere. A planet seems larger the more light it filters off. Researchers can identify the molecules that make up the atmosphere by using a technique known as spectroscopy to examine how much light is blocked by the planet at various wavelengths. The goal of NASA's transiting Exoplanet survey satellite is to find planets smaller than Neptune that transit stars bright enough to permit subsequent spectroscopic studies that can provide information on the makeup of their atmospheres. Thick clouds on Neptunian exoplanets frequently prevent any light from passing through, masking the signature of the molecules in the atmosphere. Exoplanet atmospheres will be easier to study with the James Webb Space Telescope. The Neptune-sized planet HAT P11b's beautiful sky thrilled astronomers. They were able to distinguish water vapor molecules in the exoplanet's atmosphere since there were no clouds to obscure their view. The amazing HAT P11b resembles our own Neptune in that it is gaseous with a rocky core. Researchers can identify the molecules that make up the atmosphere by using a technique known as spectroscopy to examine how much light is blocked by the planet at various wavelengths. The goal of NASA's transiting Exoplanet survey satellite is to find planets smaller than Neptune that transit stars bright enough to permit subsequent spectroscopic studies that can provide information on the makeup of their atmospheres. Thick clouds on Neptunian exoplanets frequently prevent any light from passing through, masking the signature of the molecules in the atmosphere. Exoplanet atmospheres will be easier to study with the James Webb Space Telescope. The Neptune-sized planet HAT P11b's beautiful sky thrilled astronomers. They were able to distinguish water vapor molecules in the exoplanet's atmosphere since there were no clouds to obscure their view. The amazing HAT P11b resembles our own Neptune in that it is gaseous with a rocky core. Although there may be clouds in its atmosphere, farther up, Hubble, Spitzer, and Kepler's combined observations revealed that there are none in the upper region. Due to the clear visibility, researchers were able to identify molecules of water vapor in the planet's atmosphere. Because they orbit further from their stars than those in the area where scientists would expect to find hot Neptunes, the majority of the known Neptune-sized exoplanets, like HAT P11b above, are only warm. The enigmatic hot Neptune desert argues that either these extraterrestrial worlds are uncommon, or that they were numerous once but have since undergone transformations. Hubble has recently revealed that one of the Neptunes that is thought to be the warmest, GJ 436b, is shedding its atmosphere. Although hotter Neptunes might not have been as fortunate, that planet isn't predicted to vanish completely. An atmosphere can become so heated by a star's powerful radiation that it is able to break out of the planet's gravitational pull like a free-floating hot air balloon. A massive cloud of escaping gas surrounds the planet and evaporates into space. This may be the situation for the planet GJ 3470b, which is described as a very warm Neptune, and is losing its atmosphere 100 times more quickly than GJ 436b. About 3.7 million miles or 5.5 million kilometers separate the two worlds from their sun. That is a tenth of the distance between the Sun and Mercury, the innermost planet in our solar system. GJ 3470b may be evaporating more quickly than GJ 436b due to its less dense composition, which makes it less able to gravitationally hold onto the heated atmosphere. Both planets revolve around red dwarf stars. However, GJ 3470b does so around a considerably younger star than GJ 436b, one that is only 2 billion years old. The planet receives more scorching radiation from the younger star because it is more active than GJ 436b. The discovery of two evaporating, warm Neptunes supports the theory that these typically far-off worlds may constitute a class of planets in transition. It's possible that hot and extremely heated Neptunes will eventually become mini-Neptunes, planets with dense atmospheres, dominated by hydrogen, that are larger than Earth but smaller than Neptune. Or they might shrink even further to become super-Earths, which are larger, stonier analogs of Earth. Neptune-mass worlds may be the most typical sort of planet to develop in the frigid outer regions of planetary systems. According to a study, the discovery of planets using gravitational microlensing was the main focus of the study. The study gave the first clue as to the kinds of planets that may be lurking at the distance from a host star, where planets are thought to form most effectively. We've located what seems to be the ideal range for cold planet sizes. We come to the conclusion that Neptune-mass planets are roughly 10 times more frequent than Jupiter-mass planets in Jupiter-like orbits. They discovered that cold, Neptune-mass worlds are likely to be the most prevalent types of planets beyond the so-called snow line, which is the distance from a star beyond which water remains frozen during planetary formation. They made this discovery by comparing planet frequency to the mass ratios of planets and stars and the distances between them. The snow line is believed to have existed in the solar system at a distance from the Sun that is approximately 2.7 times that of Earth, which would have put it today in the midst of the main asteroid belt. Thanks for watching. If you enjoyed the video, subscribe to our channel and hit the like button. Until next time.